course. Chair Solomon, Vice Chair Finley, members of the committee, thank you for the invitation to present and share what we're doing with electric vehicle charging. My name is Kyle Rowe. I work with Electric Era. We're a Seattle-based company dedicated to bringing the future of car refill. Next slide, please. Before I dive into our technology, I want to frame the discussion with two challenges facing the EV charging industry: demand for electricity and charger reliability. First, let's talk about demand for electricity. So EV adoption looks like this, the chart on the left, in most of the country, but Oregon sits actually at third in the country in terms of EVs as a percentage of total market share. So they're sitting at roughly 16% of total light-duty vehicles being purchased as electric vehicles. DCFC deployments, DCFC is direct current fast charger, so level 3 charger, are increasing as well. That's the chart on the right. It's not at the same rate as the market for purchasing electric vehicles, but it is picking up, and the federal programs to fuel this investment is just getting started. So we'll likely see this chart continue to keep up with the adoption of EVs. Next slide, please. With that increasing market share comes increasing demand for electricity. So the graph on the left shows the Portland General Electric's forecasted energy use growth. As you can see, compared to building electrification, which was also called out in their study as having increasing demand, the demand from electric vehicle adoption is much bigger. And while this total projected load on the grid is only 10% of the load's base grid, it's a little bit of a different picture when you zoom in to an individual day. So the bullet points on the right I'll be going through. This is from Oregon Department of Energy's Zero Emissions Vehicle Report. And they laid out really clearly, essentially, when demand peaks during the day, the cost of power goes up. Those costs eventually get passed on to the utility customers, and EV loads peak at the same time as the rest of the grid. Looking beyond the cost, we know that many utilities need to pull from peaker plants during their peak load times, which are more polluting facilities. A microscale version of this also exists at the charging station owner level. So when many cars pull up at the same time, when demand peaks, and they pull demand all the same, they pull from the same charger, the same station, many different chargers, that makes the economics of a charging station difficult because it increases demand charges on their bill. Next slide, please. So that's the first challenge. I want to talk about the second challenge, which has been plaguing the industry, which is reliability. So any EV driver knows that reliability of DCFC chargers is a big problem. This sentiment has been found in recent studies. So on the left here, we're looking at a UC Berkeley study. They visited 657 DCFC chargers, found only 72.5% of them to be working. The problem is getting worse, unfortunately. So on the right, we're looking at Plug in America data. Plug in America is an advocacy group that does an annual survey of EV drivers. And looking at 2022 to 2023, the concern about EV chargers being functional and the power coming fast enough has been increasing as a problem stated by the drivers in these surveys. This survey includes over 3,000 drivers. Just 2 days ago, OPB published an article about charger reliability as a problem that's plaguing Oregon EV owners. So we know this is a major issue. I want to go to the next slide, please. This brings me to Electric Era. So our CEO, Quincy, he was born and raised in Oregon, founded this company back in 2020 after a long tenure at SpaceX. Shortly afterward, he brought in a few other SpaceX colleagues to own the hardware and software expertise of our company. This team that now owns the Electric Era product previously led the Starlink program. Starlink runs a satellite network across the globe, provides internet all over the globe. This team was responsible for developing everything from product design, conception, production, and distribution of satellites around the globe with that uptime to provide the Starlink service. So a lot of people ask, how did you get from rocket scientists to EV charging operators? For us, it's all about using software-enabled tools to guarantee a high and reliable uptime. Now we're a team of about 20 people and growing. We have projects in the ground, many being actively built, and we have a simple mission: make EV charging reliable, cost-effective, and ubiquitous. Next slide, please. And this slide is a little busy, but I'll walk you through it. So this is why I wanted to explain how our station works and how we solve those two problems I discussed at the beginning. So our power node station stacks battery power on top of grid power to create an AC microgrid that can charge at a high power with a small grid connection. This reduces the CapEx for grid upgrades and the OpEx from demand charges. We have a battery that's in parallel with the grid, which pushes power to the chargers. It's cost effective, we can go to market quicker, all without sacrificing sessions per day and customer experience. So circling back to the grid challenges discussed earlier, this means that we can meet high demand while the utility only sees a flat energy pull from the charging station. So that graph in the middle on the right shows the the electricity coming from the grid versus the battery, and the top part being when we stack the battery on top of the grid. Essentially, we're using that battery energy storage system to flex the load and maximize our station's contribution to EV charging while minimizing the contribution to the peaks, the grid demand peak.
Sir, you mind just because?
Oh, yeah, sorry.
Vice Chair Finley has a question and he might
Please.
be related to this.
I find this fascinating. So, thank you, Madam Chair.
Yeah.
Yeah.
So, is your output of your chargers down
Yeah.
at the bottom of the graph on the left,
Yep.
can it exceed the capability of your battery pack and your input power? So, would they slow down the charging time, or would they just say, sorry, we're done till we can recharge?
So it can go to the limit that we can provide the battery plus the grid on top of each other. But it's not as simple as just putting them on top of each other. It uses AI to look at the demand from the grid and the rates associated with that, and provide the power to the charger. There's also, so EV charging is quite, it's a little more complex than simply filling up at a gas pump, because different cars will request different amount of electricity based on what kind of car they are, but also how full their battery is. So we're taking all these different data points and balancing the combination of grid and battery to give each driver that's requesting power at the same time the experience they expect. EV drivers get to expect, my car can pull this amount of kilowatts and this charger's not providing it. That's a low customer experience. So we balanced all those factors to give each driver who's pulling electricity at the same time high customer experience while keeping the demand charge low. Does that make sense?
No, it does. So I assume the objective of that is to have perhaps a more favorable power rating or charge or billing charge from the power company.
Exactly.
If you have a constant load.
Exactly. So we'll talk about this with our first station, which we installed in Portland, where we only had 25 kilowatts from the grid, but we're delivering 150 kilowatts into the car, which is exactly what I think you're referring to.
Okay.
Yeah.
Thank you, Madam Chair.
Yeah.
Great question. Next slide, please. So the California Energy Commission has their eye on this problem as well. In this graph, you're looking at forecasted grid demand in a 24-hour day with or without load flexibility. As you can see, they forecasted a much higher cost if EV charging is not managed with load flexibility solutions just like our power node station. And for this reason, the CEC is putting $21 million into research and development grants for companies to design technologies just like our power node technology. So they've identified that the grid will have this bigger load around 9-10 p.m. Unless we build technologies like this that flatten it and balance it throughout the day. Next slide, please. Our very first public charging station was installed last October in Portland, Oregon, near the airport. This site, like I mentioned, we only had 25 kilowatts of grid power, but because of our power node technology, we're able to deliver 150 kilowatts to the drivers. The same technology that flexibly balances the demand from our stations can amplify the power the station can deliver and inherently speeds up implementation timeline by avoiding expensive grid and transformer upgrades. Since launching, our power node station at Plaid Pantry has had a 99.5% uptime. Next slide, please. So in summary, I wanted to share that charger reliability and grid demand are issues to keep an eye on. We have proven that technology can innovate around these issues. Just takes a little bit of rocket science.
I got it.
Thanks. I also wanted to flag 2 upcoming programs that ODOT will be implementing very soon and just briefly discuss what's going on there. So the National Electric Vehicle Infrastructure, or NEVI program, we're anticipating ODOT will release the procurement for that any day. We're very excited to participate. We've been planning for it for a while. And we're excited to have been awarded sites in other state NEVI programs. And secondly, the Electric Vehicle Charger Reliability and Accessibility Accelerator. It's a mouthful. So ODOT was just recently awarded $10 million for the first round of this program. One misconception, and this was actually kind of reflected in the OPB piece, and it's common with this program, is that this program seems to have the notion that it's specifically for replacing broken chargers with, fixing the broken chargers. The funding is also eligible for replacing the broken chargers with ones that work better. So I wanted to make sure that everyone's aware, with reliability being measured at 72.5% and getting worse, we urge agencies to not replace broken chargers with more bad chargers, but replace them with proven tech that has demonstrated high uptime. And that's all for me. Happy to answer any questions.
Senator Golden.
Yeah, I have a crystal ball question, Madam Chair. So I'm looking at that slide, the non-functional machines and how they're getting, the ratio is not getting better.
Yeah.
When do you think we'll really feel a difference in Oregon? Are we a year out? Are we 5 years out? When are these graphs going to look real different?
Different as in the reliability getting higher?
Higher reliability, higher satisfaction.
So that's a great question. I would say that there are a few things that come to mind for me. One, the NEVI fund, that's the big pot of money that was recently made available, the biggest pot of money. There's a few. That one mandates a 97% uptime. There have not been, we have not seen individual states lay out specific plans for how they expect to enforce that via any sort of data sharing schema or auditing. We've seen in the draft contracts for these programs that they retain the authority to go and measure uptime, but with how much bad charging tech there is out there, we would hope and we would expect for our stations that there is an expectation and measuring of those uptime. So I would say the fact that the federal government put that in the eligibility requirements to receive the federal funding, because the funding is given as the 5-year term of that contract plays out. So what they're saying is if we find your uptime is below that, we may choose to not continue to pay your invoices. So that's one. The fact that there's now a fund to fix and, in our hope, replace bad hardware from incumbent players that have really big uptime challenges, that's also an opportunity to hopefully flip the script and replace those ones that are just problematic out there with better technology. When will that happen? It's hard to say. It's going to be a couple years, in my opinion.
Okay, we'll come back in a couple of years and we'll check you out.
We'd love to come back with our uptime reports in a couple years. Let's put it on the calendar.
Thank you, Madam Chair.
Any other questions?
Any other questions? I don't see it. I thought I remembered something when you gave a presentation before. Didn't you have a monitoring system that knows when? Isn't that?
Yeah, so this is fault detection incident recovery is a principle that our SpaceX engineers that came over from SpaceX to Electric Era brought into our space that allows for our technology to remotely detect an incident and potentially, in many cases, automatically correct it when keeping the charger up. Essentially, that's the main thing is automatic. We do everything we can to avoid having to send a crew out there to manually fix the charger. Instead, we build software that does that for us remotely. Should we need to, we have a 4-hour SLA to go and fix a charger. And the other thing I'll add there is that we are a full turnkey solution, whereas unfortunately another thing that's plagued the industry is that it's piecemeal. If you want to have a charger, you have a different company for the hardware, different company for the software, different company for maintenance. We bring that all in-house. So the same people that are going to be identifying the issue in our office will be the ones talking to the crew that's on the site and making sure that it's quick and fixed, and not this pointing fingers at who's responsible for the issue. So that's just another, we were building our company and our product around the challenges that we're seeing, and we wanted to make sure that that's the standard moving forward.
Thank you. I appreciate that. As an EV driver, it is, it's tough when you're looking for a charge and you pull up to something and you're like, oh my goodness, this one's out or whatever. And they rely on you to call the 800 number and such. But yeah.
And the recent ice storm that Portland experienced, our charger stayed up the entire time. Yeah. And we saw demand go up because batteries have a harder time when it's cold out. Yeah. I guess folks just learned that our charger will be available.
Yeah, perfect. Thank you so much, Mr. Rowe. Appreciate you being here. And I don't see any other questions.